Hey all, okay, so we're going to talk about electrochemical reaction, which is an oxidation reduction reaction, which we talked about a while ago. We kept the balancing of those equations for a later chapter. However, we're not going to get to that chapter, and there's a chance you might see this on the AP exam. So we're going to go over it right now. So as a reminder, in electrochemical reactions, electrons are transferred from one species to another. So we call them redox, reduction oxidation reactions. And we used the letters oil rig to help us remember. Oxidation is loss, oil, and reduction is gain in electrons. Remember, when you lose electrons, you become more positive, and when you gain electrons, you become more negative, which is where that reduction piece comes from, because your charge is reduced. So oxidation numbers help us keep track of the electrons. And so we can assign those to different elements in an equation. The species that's oxidized loses electrons again. So zinc goes from 0 to +2. So the increase in charge tells us it lost 2 electrons. When it's reduced, it gains electrons. So we're going from a +1 to a 0. So in order to do that, we gain an electron. If we go down in charge. Okay. And so what happens is zinc is oxidized and hydrogen is reduced. So there are some rules when you assign oxidation numbers. You've seen these before, but let's review. Elements in their elemental form have an oxidation number of 0. That includes diatomic molecules. If it's just one thing, there's nothing to balance out the charge, so it has to be 0. The oxidation number of a monatomic ion is the same as its charge. So let's say you had Br-, it has a charge of -1, so its oxidation is also -1. Nonmetals tend to have negative oxidations, although that is not 100% of the time. Oxygen always has an oxidation of -2, except in hydrogen peroxide, H2O2, where it has -1. Hydrogen is -1 when bonded to a metal, and +1 when bonded to a nonmetal. Nonmetals tend to have negative oxidation numbers, although some are positive. Fluorine's always -1. Most of the halogens tend to be -1. The sum of the oxidation numbers in a neutral compound is 0, and the sum of oxidation numbers on a polyatomic ion is the charge of the ion. Okay, so let's try a couple of these. So we're going to identify which substances are oxidized and which are reduced. So first we need to assign oxidation numbers. So I always start with the 0. So any element by itself, like cadmium, is going to be 0. I don't see any other by themselves, so then I'm going to go with my oxygen. Oxygens are always -2 unless in hydrogen peroxide. So this oxygen is going to be -2, but notice there are 2 of them, so that's going to be a -4 overall. I like to put the oxidation numbers at the top and then my overall count on the bottom. -2 there. There's only 1 of them. We can ignore coefficients when we're doing oxidation numbers. Let's see. So this whole thing here is a hydroxide, and hydroxide is OH 1-. So the oxygen is -2. Again, we're going to kind of keep this thing together. Okay. There are 2 with my subscript out here, so that oxygen is -4 total. Okay, so now I'm going to go and fill in what I can. So NiO2, there's 2 elements. So if my oxygen adds up to -4, my nickel has to balance that out, so it's a +4. Here, my oxygens are -2 total, so I need to balance that out with a +2. Since there are 2 hydrogens, each one gets a +1. So let's go in. We've got 3 elements in these ones. So these are the hardest. So OH overall should be -1. So if the oxygen is -2, to make it -1, hydrogen has to be a +1. But again, there are 2 of them, so that's a +2 total. So inside the parentheses with 2 things, we end up with -2. So to balance that out, our cadmium has to be a +2. And then we're going to do the same process with the nickel. So -2, this has to be a +1. There's 2 of them. So overall -2, which makes our nickel +2 to balance it out. So these top numbers are our oxidation numbers. Okay. So now we're going to look at the changes. So cadmium goes from 0 to +2. And in order to go up in charge, you have to lose 2 electrons. So oxidation is loss. So cadmium is oxidized. And then the nickel goes from +4 down to +2. So the nickel is reduced, which means that it gains. Reduction is gain of electrons. Okay, try the next one on your own and then check your answer. Okay, so when I assigned oxidation numbers, I got that the water, the hydrogen was +1, oxygen was -2, the solid aluminum is 0. In the permanganate ion, the MnO4, notice that there's this negative sign here, so we have to keep it -1. So my oxygens add up to -8, which means my manganese is +7. And then I'm going to do the same process on the other side. So my hydroxides, -2 +1. There's 4 of them. And so, oh shoot, I missed this negative here. We have to keep it negative. So this one the aluminum is actually +3. And then manganate, 2 oxygens is -4, and then a +4. Okay, so let's look at what's oxidized and what's reduced. So I see my aluminum goes from a 0 to a +3. So that is going to lose 3 electrons. Oxidation is loss. So that will be my aluminum. And then my manganese goes from +7 to +4. So that is going to be a reduction or gain 3 electrons. You guys, in these, there will only be one thing that's oxidized and one thing that's reduced. So everything else should stay the same. All my oxygens are -2. All my hydrogens are +1. Okay, so if that is not true in yours, you've done something wrong. Okay, so here comes the new part, balancing oxidation reduction reactions, and we're going to do it via something called the half reaction method. So the law of conservation of mass says that the elements need to be the same on either side. Now, what we haven't really taken into consideration is that the electrons also need to be the same. And so we're going to have to look a little bit more closely at these reactions to make sure that those charges balance out. So now we're not only balancing the elements, but we're also looking at the electrons. So we're going to do something called the half reaction method. So basically what we need to do first is decide what is oxidized and what is reduced. So when we assign oxidation numbers, we see that the permanganate ion, the MnO4-, the manganese goes from +7 to +2, and so that is going to be a reduction. And then the carbon goes from +3 to +4, so that is going to be an oxidation. So what we're going to do is split those up into 2 things. So we're going to take the manganese and put it in one, and we're going to put the carbon and put it in second. So this is our half reaction for our oxidation. So what we're going to do first is balance the elements. So I see that I have 2 carbon in the reactant side and only 1 in the products. So I'm going to put a 2 in front of my carbon. So now I have 2 carbon and 2 carbon. And then I'm going to look at my oxygen. So I've got 4 oxygen on this side, and then 2 times 2 is 4 oxygen on that side as well. So my elements are balanced out. But I can see that on the reactant side, I have a -2, and on my product side, it's neutral. So I need that to balance. So what I'm going to do is balance by adding electrons. So if I have -2 on the reactant side, I need to add 2 electrons to the product side to make that side -2 as well. So this is my balanced oxidation half reaction. I'm going to do the same thing for the reduction half reaction. So first I'm going to balance my elements. So I have 1 manganese and 1 manganese, perfect. But I have 4 oxygen and no oxygen. So if you need oxygen and it's not already there, we're going to add waters. Okay, that seems weird, right? But that's what we're going to do. We're going to add waters. So if I need 4 oxygen and water is H2O, that means I need 4 waters. So you can see that in the bottom one, I've added 4 waters. Now we've created another problem because now my oxygen are balanced, but my hydrogens are not. Now I have 8 hydrogen that I need to take care of. I have 8 in the product side, but none in the reactant side. So next, we're going to add hydrogen ions. So hydrogen ions come from acidic compounds. And so when we balance oxidation reduction reactions, we're going to assume that it's an acidic environment. And so we're going to add 8 hydrogen ions to the reactant side. So now we've got 8 hydrogen, 1 manganese, 4 oxygen, 4 oxygen. So all of our elements are balanced. So now we need to look at charges. So right now we've got 8 positive charges and we've got 1 negative charge. So on this side, we have a charge of +7. On the product side, we just have this +2 here. So we have a charge of +2. So we're going to add electrons to balance this out. Remember, electrons make the charge go down. So we're always going to add electrons to the side that has a higher charge. So to get from +7 to +2, we need 5 electrons. So we're going to add 5 electrons to the reactant side. And now we have a balanced half reaction. Okay, so now we're going to put them together. And we're going to add them up just like we do Hess's law, cancel anything that cancels. Now, we know that in a balanced equation, we don't actually have any electrons. So before we can add these together, we need to make it so that our electrons cancel out. So right now I have 2 on the product side and 5 on the reactant side. I can only multiply by a whole number, and so I need to find a common multiple. I can turn these both into 10. So I'm going to multiply everything on this side by 5 and everything on this side by 2. So I'll rewrite it. So I end up with 5 C2O4 2 minus, 10 CO2, and 10 electrons. My permanganate one is 10 electrons, 16 hydrogen, and 2 of the MnO4 minuses, 2 Mn2 pluses, and 8 H2Os. Then I'm going to cancel anything that's on both sides. So my 10 electrons, otherwise everything else is going to carry down into my balanced equation. So my balanced equation is 5C2O4 2 minus, 16H plus, 2 MnO4 minus, 10 CO2, 2 Mn, 2 plus, and 8 H2Os. So this oxidation reduction reaction ends up being a very long reaction when it's balanced. Okay, so here's the process. Assign the oxidation numbers so you know what's oxidized, what's reduced. Write the oxidation reduction half reactions, break apart. Balance each half reaction, so do the elements, do the oxygen by adding water, the hydrogen by adding H+, and then do the electrons in this order here. Multiply the half reactions so that the electrons are the same, add them together, make sure it's balanced, and then you're good to go. So let's try one of these all the way through together. So first I'm going to assign my oxidation numbers. So chlorine Cl2 is 0. My Cr3 plus is just an ion, so it's going to be +3. Same thing with my chlorine. And then my oxygen is a -2. I have 7 of them, so that's 14. I need to keep my +2, so this needs to be a +12. There's 2 of them, so this is a positive 6. Okay, so my chromium goes from +6 to 3+, which means that it is reduced. So my reduced equation is going to be my Cr2O7 and my Cr3+, leaving a little room there. And then my oxidation is going to be my chlorine -1 to 1. So my oxidation is going to be my Cl1- and my Cl2. Okay, so first thing I'm going to do is balance the elements. So I'm going to take, let's see, I've got 2 chromine in, so I need a 2 here. Now I have 7 oxygen on my reactants, so I need 7 waters in my products, which gives me 14 hydrogen, so I'm going to add in those 14 hydrogen. So last thing I need to do is check my charges. So I have a -2 here, plus 14 for a positive 12 on the reactant side. And then on the product side, I have 2 times 3+, so I have 6, a positive 6. So again, I'm going to add electrons to lower the charge. So I need 6 electrons on the reactant side. Okay, next we're going to do the chlorine. So I've got 1 in and 2 out, so I'm going to put a 2 in front of my chlorine ion. So now the chlorines are balanced, and when I look at charge, I've got a charge of -2 here. So I need 2 electrons on the product side to balance. A little bit easier there. So now I am going to add those together, but I first need my electrons to be equal. So I can turn 2 into 6 by multiplying by 3. So that's going to become 6. This is going to become a 3. And this one is going to become 6 as well. My electrons cancel. And it looks like everything else is brought down. So I've got Cr2O7, 2-, plus 6 Cl1-, and 14 hydrogen. And then I've got 2 Cr3+, 7 H2Os, and 3 Cl2s. Okay, we're balanced. I want you guys to try one more on your own. Okay, so I assigned oxidation numbers, and I realized that my oxygen, or my copper is oxidized and my nitrogen is reduced. So my copper is already balanced, which means that all I need to do is put a electron. So I've got +2 on this side, which means that I need 2 electrons to balance that out. And then I'm going to do the other side. So NO3 and NO2, so my N's are balanced, so now I'm in oxygen. I have 3 oxygen in the reactant side and only 2 on the product side. So my products are going to need a water to get that 3rd oxygen, which adds 2 hydrogen. So I'm going to need to add 2 hydrogen on this side. And then the last part is my charges. So I have a -1 here, and then +2 for a +1 on this side. And I don't have any charges on my product side. So I'm going to need to add 1 electron to the reactants to get this to balance. In all of these, the electron should be added to the products in the oxidation and the reactants in a reduction. Okay, so you can check it that way. So now we need to multiply this whole thing by 2 to get my electrons to balance. So when I add that together, I have a copper, 2 NO3-, 4 H+, my electrons cancel, Cu2+ plus 2 NO2s plus 2 H2Os, because I have to multiply that 2 into everything there. Okay, that was your quick how to balance an oxidation reduction reaction.